The LiPower power station with over 2,000 watts output. Do you need it? Let's find out. This is the LiPower Mars 2000, so it has a 2,000 watt output, 4,000 watt peak output. Now that's not the capacity. We'll go over that in one moment. Let's dive in, take a closer look at each one of the details and features of this power station. Then we're going to use it on a couple of things, show you how it works in both charging as well as output. Then we'll come back and talk about pricing and where you can get it. This is the LiPower Mars 2000, and as the name implies, this is a 2,000 watt output power station. Now this is powered by a lithium phosphate battery or lithium phosphate batteries, so it's not your typical, say, lithium ion or even lithium polymer. This is lithium phosphate, which in essence there's several different reasons why they use lithium phosphate. It is a little bit heavier of a battery, so you don't see it used a lot in tools. However, in something like this, it really doesn't matter other than carrying it around. What lithium phosphate does give you are more cycles in charging or discharging a battery. A typical tool battery is going to get you probably between 500 and 1,000 cycles. In other words, you can use this and throw it on the charger 500 to 1,000 times, and by the end of that life, probably have 80–85% of its life left in the battery. But that's pretty much the life of this battery, is say 1,000 cycles, whereas a lithium polymer battery is going to last up to, way past 2,000, probably even into the 3,500 range. So you get a longer lifetime when you're using a lithium phosphate battery, and that's what is inside here. As far as tank size or capacity, we'll go over that here in a moment. It's just shy of 1,500 watts. But as far as the output, what it can output, that is 2,000 watts, and that is running. So in other words, it should be able to continuously run 2,000 watts of output, and also a peak or a surge of 4,000. So we will test that here in a few moments. Now we have several outputs here. We have typical 110, 120 volt outlets. So we get 3 of those where we can combine those and pull out up to 2,000 watts. We also have inputs here, so that's for charging. And so we have a typical kind of a 12 volt cylindrical design there. And then we have I believe this is the Anderson, is that right? Yes, this is called an Anderson connector. So in other words, we can charge it by either one of these inputs. We'll go over everything that comes with in just one moment. We get several USBs. You can see we get 3 USB-A. One of those being 3.0, so in other words, we get a 3 amp output there, and then we get the high charging USB Type C as well. So Type C as well as the USB 3.0 are going to give you 3 amps output, and then we have a DC port here where we can plug in your typical 12 volt accessory or cigarette lighter style that we see in automotive for decades, as well as our 12 volt plugs here as well. Now with the power station, we get this nifty little bag here, which kind of holds all the different chargers, as well as even your warranty card here, and even your user's manual, which, by the way, this is a very condensed user manual, but very easy to read, very quick to read, and full of good information. It's really not a lot of wasted space. So they got some good info in there. I was pretty impressed by the size and the ease of reading for that user's manual. It's definitely worth flipping through. And let's take a look here in the pack. Now here's our transformer for actually charging this unit, and we're going to have our typical DC 12 volt plug there. We can plug it in the input, and that's how we're going to charge it. And then from the transformer here, we can plug in with 120 volts or typical household current and plug this into here and charge it that way. We can also charge it from your typical, again, 12 volt accessory or cigarette lighter type plug, and then that's going to plug into there as well. And then many of your solar panels have these types of connections here where you can plug in a positive, a negative, and then and plug this in to charge that way also. So if you have your own solar panels, this plug actually comes with this, so you can plug that in and use them. And it's pretty cool that all this fits into this nice pouch. Then you have access to it if you need it. Real simple cube design here. I'll flip this around. So you see basically a grill here on one side, which that's probably like an intake, because here's the back side, which is solid, and the other side, which are, you can see like two PC fans, and they're exhausting air out the back. So I'm sure the other side is intake, pulling air all the way across, probably the batteries as well as all the circuitry, and exhausting right here. Now the top side, pretty solid design with two big handles here that are very solid construction, so very easy to handle this. It is a heavy unit, it's not light by any means, but you have some nice beefy handles to be able to hold on to this. Size, about 13 inches tall, and handle to handle about 13 1/4. And as far as depth or width, about 9 inches. So pretty compact unit. I'm just curious, I'm going to throw this on its back, and I'm wondering if it will stay running or if it will kind of air out. Some useful information here on the back. You don't have to open up the user's manual, and it talks about all the outputs, the inputs, so battery type, as I said, LiFePO4, which is lithium phosphate, 1460 watt hours is basically capacity, and then it says rated power is 2000 watts or surge of 4000 watts, and then tells us basically pure sine wave at 60 hertz and USB-A, and then the USB type 3.0 or USB-C 3.0, and so on. So it basically gives us all our ports and what they're rated at, and then even solar charge input anywhere between 18 and 30 volts. Just wanted to mention that because that seems to be pretty useful information there on the bottom of the machine. Now the unit is running and the fan is running, and so I wanted to give you, I'm going to put the mic right there at the fan. So it looks like the loudest is like 76 decibel. And that's with your ear right here. So you can see just a foot away and we're down in the 50s. Now let's just run through real quick some of the operation here, and then we'll get right into actually testing this. You see we're charged at 100%, and it shows your input, which is at 0, and your output, which is at 0 as well. I like the fact that right there on the main screen, we're going to be able to see what's coming in and what's going out. Now let me point out right away, because a lot of times one of the first questions is, can you charge this and use it at the same time? Yes, you can. However, they frown upon that because it's just bad for the battery. It's kind of double taxing the battery, if you will. So you're kind of hitting it both sides. And I would probably argue that's probably going to affect your cycle, your number of cycles. If you can get 3,500 charge cycles in a battery and you're constantly doing that, you could easily be cutting that in half. Don't mark those words as absolute science, but I do know they frown upon it because of the battery life when you're attacking it from both angles in the charge and discharge. So basically each one of these, we can turn these on and off. I can turn the USB on, I can turn it off, I can turn the DC on, I can turn the DC off, and then you see it gives us a fan logo when the fan is running, and that's going to automatically come on when there's either a load on it or when it's actually, maybe too hot. Probably the case right now, it will actually trigger that to come on. Also, if I want to turn the AC on, hold the button down, and it's going to call that on. Now, here's something cool about the AC, because this can be used anywhere. A lot of times, some places use a 60 hertz electricity and some use 50 hertz. We can change that just tapping the AC button 5 times, and you'll see right here it just changed to 50 hertz. 5 times again. Now it's at 60 hertz. So you can change from 50 to 60 hertz. And as I mentioned, pure sine wave. So all your electronics are going to be absolutely safe charging on this, whether you're using the USB ports or using the standard outlet ports as well. Now we measured this, so let's now get a weight on it. So a little over 37 pounds, 2.5 ounces. So while it's no, feather to carry around, it is under 40 pounds. And to be able to carry around a generator, if you will, that's pretty light. Now let's go over a couple of simple things right now. And that is, Think of this as nothing more than a big battery pack or a big fuel tank. I know you're probably thinking, well, what did you think I think it was, Tim? Anyway, because we think of it as a generator, obviously, but a generator, you can fuel it and create more electricity. This is basically going to only hold how much electricity it can hold. In other words, those 1,460 watt hours. And unless you're recharging that by some way, then it's only going to output that 1,460. And arguably, you may even want to take a 85% efficiency rate on that and say it's only going to take or deliver 85% of that, because it's running a fan right now. So it can't be 100% efficient in putting out every bit of power that it has, because it has to run the fan, arguably this LCD screen, and so forth. You get it. So whatever power's in there and whatever power it puts out, that's what it's going to drop this by. So my point is, I like to think of this as something not only that we can keep on a campsite, but also maybe somewhere in our truck, on a job site, somewhere remote where we need to, and my thoughts automatically go to charging tool batteries. And so that's what we're going to do here. So I've got a couple of nice here's the Milwaukee supercharger. This is Flex's supercharger. And we're going to plug these things in and just see what type of power output we're getting and how much draw. And here's just an example here. So this M18, so 18 volt, 12 amp hour battery has 216 watt hours. So you would take your 1460, which is what this holds, and you're going to subtract at least 218 watt hours or 216 watt hours from that amount. There's no magic. There's no, little monkeys in there turning a wheel, or little hamsters in there turning a wheel that magically making little electric pixies. So when we go to charge, it's going to remove that power from that battery and put it in this battery. And that battery's charged. That's not going to help us. Let's go to the Flex, see if we can get this one to charge. Yeah, so now we're charging on this. And you can see here that it's saying 99 watts and it's climbing 131 watts, 190 watts, 241 watts, 267. So it keeps climbing. This is supposed to be able to do up to 550. It's climbing 507, 549, 554. Okay, so there we are. Now it's pulling 554 watts. So in an hour, it would pull 550 watts out of that 1,460 watt battery. Now the thing is, this battery is only 240 watt hours. So in about 30 minutes, it's going to be done charging, and that's all it's going to pull out of there. So we would remove 240 watts from this, even though we really don't have to, because we're almost charged up anyway. So we don't have the full battery to charge, but just understand, it's just going from here to here. Throw another battery in here. There we go. Now that one's going to charge. And we should see this climb a little higher. So now we're pulling 709 watts out of this guy right now. See, now we've dropped to 99%. So we definitely have no trouble charging two superchargers. So this is the Mac Daddy charger for Milwaukee. This is the Mac Daddy charger for Flex. We've got both of them running and charging batteries right now off of this power station with no issues. Now we're going to push this a little bit harder. Got two plugs here. And as you can see here on the right, I've got a board full of 500 watt light bulbs. So each one of these I call on will actually call on two bulbs, which should be about 1,000 watts. So you'll see if I call this on, it's pulling right at 870 watts here. So what I'm going to do here, we're going to test the 2,000. In other words, will it constantly run roughly 2,000 watts? And then we're also going to call on 4,000 and see if it will, at least for some amount of time, run that 4,000 or run those 8 bulbs without tripping out, and then see how long it'll take before it does trip out. Okay, there's 1,685 watts right there. 1725. Now let's call it another one. Okay, now we're at 2260, 25, 2520. See how long it's going to run. See if it trips out here. Wow, it's constantly pushing out. 2450, 2430. Up, and there it just tripped out. So it ran that for a good 20 seconds before it killed that. So now it basically just shut down these ports and is not going to allow me to run that. Now what's interesting is the unit stayed on. It's also given me a code here. So you see that number 5 code? If we go in the back of our manual, toward the back, right here, code number 5, AC overload protection. Press the AC button for 3 seconds to recover function. So I've turned my switches off, 1001, 1002, 1003. Okay, probably have to turn it back on now. There we go. So now I can run my lights again. So we ran that, say 2,500 watts for a good, 20, 25 seconds. I'm going to go ahead and call a little more than that. So there's our 1750, 1690. So let's call it 1700. And now I'm going to flip 2 more on. Now it's at 3250. Now it went out. So looks like anything over that 2000 range kind of trips it out within, say, 10 seconds or so, probably depending on how much power it is pulling. And there may just be some type of heat sensor in there that's triggering that. And just to see, we're going to go ahead and hook up a third one. And so that's 1800. $33, $34, 27, 3500, 3700. So looks like we got up to 3700 and it finally dropped out. So we're definitely getting close to that 4000 peak. So still pretty impressive. So we got 2000 sustainable. And by the way, this is pretty hot. I think that's from my lights though. They generate a ton of heat. And now we're down to 94%. But just understand, these types of lights are just a pure dead short on those batteries. Now you'll notice back here behind the Mars 2000 are these nice pouches here. We've got 2 of them, and these are the 100-watt solar panels from Lipower as well. Now what's cool about this is if you open this pouch here, user manual, and then we have the Anderson connector, as well as just a 12-volt connector that will bridge 2 units as well as go straight to the charger. So we have a little brick in here, and right from that brick, this is pretty cool as well. You can see there's the charger port, that 12-volt cylindrical design. Then we have a USB Type-C and USB Type-A's right there built into the solar panel. So you can literally put this solar panel out, be able to charge your cell phone or smart devices. And by the way, these are USB 3.0s as well. So these 2 USB A's are 3.0, and then a USB Type-C, and then the typical 12-volt cylindrical design. We're going to go set these up. Pretty cool folding solar panel. Now these Lipower solar panels are really cool. Number one, they just come in a really nice pouch with a handle on it, so they're easy to carry around, and everything's included right here in this. So we have 2 clips here. Going to open this up almost like a little briefcase or a portfolio or something. And then we have a pouch here on the back, which I already showed you, where you have kind of your charging block and output block, where you hook up your cords. And by the way, if you're not aware of these, you can just plug this in and it actually works. But like when you're plugging it in this block, you can also do a twist and it will lock into place. So give it a good quarter twist and you'll feel it kind of bottom out, and that locks it in so that when it's hanging upside down like this, it's not going to pull out. So as it's locked in, whereas if I just plugged it in and pulled it, it's going to come right out. So push it up, give it a turn until it kind of locks into place and you'll feel it. Anyway, so we'll hook this one up. This is the Anderson connector, which has got the red and the black on it. So I'm going to hook this up here, give it a good turn, and I could even zip part of this up if I wanted to. Just kind of lock that cord in there. And then these things are just going to open up. So you've got 4 panels in here. And not only that, when you raise this up, you've got 3 different kickstands here. So there's Velcro here at the bottom. It expands out. You have a little elastic bands there. And then it kind of uses as a kickstand to lay those panels out. And like I said, there's 3 of these between the 4 panels. So it provides plenty of standability, if you will. Don't know if that's a word, but it works. So it's cool that they're built right into that, and then just lift it up and that elastic band pulls it into place and Velcros it, and now they're out of the way, and now you can fold it up. And actually laying down like this is what we found the best use, because the sun was directly overhead. So this had a better angle and really doubled our output. I think we went from getting like 83 watts to right at 150 watts or close to 160 watts out there with them laying down. So you want to play with it, play with the angles to get your best output. And as we talked about, we're just going to take the Anderson connector, red to red, black to black, plug that in, and that's going to start charging as long as you've got sunshine on here. And by the way, we got this with 2 of the solar panels, and this can be used for 1, or you could double them up and use them for 2. And then we got this Y connector here. So this was a little extra. This is a double Anderson connector so that we can plug it in here, and then we can plug both panels into here. You can also connect these with the barrel connector as well. The 12-volt connector will go from box to box, but then you need to output to something else to be able to get to the charger. So this was just a few bucks extra, and we just keep it right here in the solar panel pouch. Very convenient solar panels. First off, the great thing about the LiPower Power Station is that it's powered by the lithium phosphate batteries. And why I explain that's so great is because you're going to get a lot more cycles of charging out of the lithium phosphate batteries as opposed to lithium ion. Lithium ion typically caps out at around 1,000 cycles, and this is going to cap out at somewhere around 3,500. Now, the interesting thing is, I know the industry kind of standard is 3,500, but LiPower notes just 2,000 in their user manual. Now, they may just be trying to be safe on that, so I just wanted to point that out, that again, the industry standard on lithium phosphate is typically around 3,500 cycles, but again, as you'll see in the manual, it states 2,000. Now, the lithium phosphate is a little bit heavier, but in something like this, I don't think you really care of whether you're carrying, 5 more pounds to the campsite or to the truck or to the job site than if it were just a little bit lighter. I don't think that's going to be a big deal for you. Now, if you're putting this on your back and carrying it around, or if you're putting it on your hip like a power tool, I get it. You would always want those ounces will add up very quickly. Now, as far as peak output, I think we got up somewhere close to like 3,700 before it tripped out, and it's only going to do that for a few seconds. It did sustain like 2,500 for, say, 20 seconds or so before it tripped out. But again, you're going to need to stay somewhere around that 2,000 and lower range for it to stay sustained and outputting that much power. And as I mentioned, you have to think of this as kind of power in, power out. Jesus is not in there converting dust into electrical pixies. Power from the battery out to whatever you're powering, and then that's it. You need to recharge this. Now, there's a lot of information in the user's manual, as we were talking about small fridges and how much power they take, and microwaves and blenders and that sorts of things. I kind of relate this to power tools and charging batteries and that sort of thing, and understanding kind of a high capacity battery is going to be in that 200 watt hour range, but you're never running that all the way dead and having to charge it. So also keep that in mind as well. Now, on the on the solar panels, we were able to pull about 160 watts when we put both of them out there. So we're not pulling a full 200. You may be able to get close to that 200, but you'd have to have them kind of perfectly aligned with the sun and that sort of thing. And then obviously whatever you've depleted from here, that's how long it's going to take to charge it. Again, those charge times are in there as well, but you can do that math for yourself. If you're down to, say, 200 watt hours and this is 1460, well, you've got to go to 1260, and if you've got 200 coming in, that's going to take about 6 hours to charge. But again, a lot of that can be just math to be done without having to actually look and see how long it's going to take. You can do that math on a piece of paper or in a calculator on a website. Price on this is right at $1,500. I think $1,499 for the Mars 2000. They also have a Mars 1000. They have even smaller units down to, I think, even like 300 watts, things like that. But this is a really cool unit because it's handling a lot of power in here. You can use this during power outages. You can use this on a campsite. You can use this on a job site. Now, also, these solar panels are additional. They're like $240 a piece. So you're looking at about another $500 here. So all in, you're looking at about a $2,000 outlay. Yes, that's a lot of money. But again, if it's something where you need constantly to be able to run off the grid, if you will, or as you know, on many job sites, you're sharing one power pole. If you're needing to recharge those cordless batteries, this is a great option to do that. And you can throw some solar panels out there and be recharging it, or utilize whatever extra port that's on that temporary power pole to recharge this battery. So check it out for yourselves. You can find them at Amazon. We'll have a link in the description. Also, keep track of us on Instagram, Facebook, Twitter, and even TikTok. And if you don't mind, would you hit that like and subscribe button if you haven't done so already? And by all means, if you hated our video, then give us a thumbs down. But would you let us know in the comments why? Have a great day and keep smiling.